Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to discuss solving inequalities, which has a very high likelihood of appearing in the arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. More specifically, I want to start today's video by giving you a review of the rules for solving and graphing inequalities. And later in today's video, we'll work on some one-step inequalities. In a separate video, which I'm going to upload very soon, we'll do some word problems with inequalities. And then finally, in a third video, we'll work on solving some two-step as well as multiple-step inequalities. All that said, let's get started with today's video. To start, let's talk about the different types of inequality signs, and these are signs with which most of you are already familiar. There's 4 of them, namely a less than sign, a less than or equal to sign, a greater than sign, and a greater than or equal to sign. My goal is, if you're not already familiar with these signs, that is, you can't just look at it and identify what type of sign it is to get you not only to be able to do that, but to be able to solve inequalities without thinking too much about them. So let's take a look at the next slide. There are some graphing rules with which you need to be familiar as well. Specifically, there are 4 of them. And as far as graphing rules go, we're talking about graphing on a number line. Okay? In case you haven't seen this in a while, let's go ahead and do an illustration. So to graph an inequality on a number line, you simply place an open or closed circle above a value that you're given, and then you write an arrow either in the left or right direction, implying that all those values are either less than, greater than, less than or equal to, or greater than or equal to that value. But just for illustrative purposes, let's do these not on a number line. So if we have the less than symbol, we know we're going to be working with an open circle, and the direction of the arrow is going to go to the left. Similarly, if we have a greater than symbol, we know we're working with an open circle again, and the direction of the arrow is going to go to the right of the number line, on the number line. Finally, if we have less than or equal to or greater than or equal to, we're going to use a closed circle for both of them, and less than or equal to is going to go to the left. That's a bad line there, so let's redo it. And greater than or equal to is going to go to the right. So let's take a look at a few examples of those. In this example, we have x less than 5. So on our number line, we go to 5. We place an open circle above it. And since we're trying to represent all the x values that are less than 5, we're going to draw a line with the arrow going to the left, given that all these values, 4, 3, 2, 1, and 0, are all less than 5. Okay, so that makes that a true statement. For this one, we have x greater than negative 2. So the first thing we're going to do is go to negative 2 on our number line, place an open circle above it, and then draw an arrow going to the right, implying that all these values under this line are greater than negative 2. And as we can see, they are. Negative 1 is greater than negative 2, 0 is greater than negative 2, and so on and so forth. We have x less than or equal to negative 8. So as we can see, we put a closed circle above negative 8, and then the direction of the arrow goes to the left, implying that all these values under the line are in fact less than negative 8, which they are. And finally, we have x greater than 4, greater than or equal to 4. So we place a closed circle above 4 on the number line, and the direction of the arrow goes to the right, implying that all these values under the line are in fact greater than or equal to 4. Okay, so let's work on a few of those examples ourselves. If you want, you're more than welcome to pause the video and do these on your own scratch paper. The first one says x less than -6. So above -6, we're going to put an open circle. And we want all the x values that are less than -6, which are in this direction to the left. So we're going to write our arrow to the left. For this one, it says x is greater than 2. So right above +2, we'll put an open circle. And similarly, we're interested in all the x values that are greater than 2, which are these 2, 3, 4, 5, 6, 7. So we're going to put a line down with an arrow going to the right. X less than or equal to 0. So we're going to place a closed circle above 0, which implies that we include 0. And we're interested, as you can see, in x values that are going to be less than 0, which are -1, -2, -3, and so on. So we're going to draw an arrow to the left. X greater than or equal to -7. So the first thing we're going to do is put a closed circle above -7. And in this case, we want all the x values that are greater than -7, -6, -5, -4, -3, and so on are all greater than -7. So in other words, our line's going to go to the right, implying that all those values are greater than -7. Okay, so as far as solving inequalities goes, it's just like solving equations. That is, your goal is to get the variable to one side of the inequality and everything else to the other side of the inequality. That said, there's a small rule that trips most people up. If you divide or multiply by a negative number across the inequality, you have to switch the sign. Okay? And finally, the only other difference between solving inequalities and solving equations is that whereas you graph equations on a Cartesian coordinate plane, you graph inequalities on number lines. Okay? So again, devote this rule to memory so that you don't get these wrong. In this slide, they gave us the example -7x is less than 21. Again, we're treating this just like an equation insofar as we're trying to get x by itself. So to do that, we're going to divide both sides by -7. This crosses out, leaving us with just x. That said, since we divide it by a negative across the inequality sign, that's going to prompt us to change the direction of its sign. 21 divided by -7 is, of course, -3. Okay, so that was that example. If we were to graph this one, we would find -3 on the number line, put an open circle there. And this says we're interested in all the x values that are greater than -3. So we would draw our line to the right accordingly. This goes into more detail. Again, when solving inequalities, if you multiply or divide by a negative, you must switch the signs. That is, less than becomes greater than becomes less than, and so on and so forth. And this one just gives us an illustration of dividing across the inequality with a negative. So let's go ahead and work out this example. We have -5x is less than 20. Again, we're treating this like an equation where we want to get x by itself. So we're going to divide both sides by -5. This crosses out, leaving us with x. And since we divided across the inequality sign with a negative, that's going to prompt us to change its direction. 20 divided by -5 is -4. Okay? In this case, they multiplied across the inequality sign by a negative, which again is going to prompt you to flip or change the sign's direction. So let's go ahead and work on this example. They gave us -x over 5 is greater than 2. And again, I like to write this like this: -1/5 x is greater than 2. It's just easier for me to work with when it's written this way. And so we want to get x by itself, so we're going to multiply negative 1/5 by its reciprocal, or negative 5. And we're going to do that to the other side as well. Negative 1/5 times negative 5 is positive 1. Positive 1 times x is just x. And that leaves us with x is greater than, and since we multiplied by a negative across the inequality sign, that's going to prompt us to flip its sign, or change the direction of its sign. And that leaves us with x less than 2 times negative 5, which is negative 10. Okay, just an illustration of what you do when you multiply or divide by a negative across the inequality sign. Okay, so in the remainder of this video, there's going to be 8 practice problems illustrating how to solve one-step inequalities, including with multiplying and dividing across the inequality sign with negatives. So if you're comfortable with this material at this point, I advise you to pause the video, work out these problems yourself, and then play the video to see if you and I came up with the same answers. So the first one says x plus 6 is less than or equal to 7. Again, we're trying to solve for x, so as we would while working out an equation, we're going to try to get x by itself by subtracting 6 from both sides. This crosses out, leaving us with x is less than or equal to 7 minus 6, which is just 1. Again, you only flip the inequality sign when you multiply or divide across the inequality by a negative. In this case, we subtract it across the inequality, which is fine. Okay, so this one is x is less than or equal to 1. This one says 3 is less than x minus 5. Again, the goal is to get x by itself. So as we would while working out an equation, we're going to add 5 to both sides. Negative 5 plus 5 is 0. So that leaves us with 3 plus 5, which is 8, is less than or equal to x. And again, we did an addition across the inequality sign, so it doesn't affect the direction of the inequality sign. All right, number 3. Negative 3x is greater than or equal to negative 15. Again, we're trying to get x by itself or isolate the variable. So that's going to prompt us to divide both sides by negative 3. This crosses out, leaving us with just x. Since we divide it across the inequality sign by a negative, that's going to prompt us to flip the direction of the inequality sign from greater than or equal to less than or equal to. Negative 15 divided by negative 3. Negative divided by a negative is going to be a positive 5. Again, if you need to see it, here's the signs chart. Let me go ahead and put that up real quick. This is the signs chart, and it's applicable to both addition or multiplication and division. And this is how you use it. If you have a positive times a positive, the result's going to be positive, or the product's going to be positive. If you have a positive divided by a positive, the result's going to be positive. If you have a positive times a negative, the result's going to be negative. If you have a positive divided by a negative, the result's going to be negative. If you have a negative times a positive, the result's going to be negative. If you have a negative divided by a positive, the result's going to be negative. And if you have a negative times a negative, or a negative divided by a negative, the result's going to be positive. In this case, we have negative 15, so that's negative, divided by negative 3, which is negative. So therefore, we know our answer is going to be positive. More specifically, it's positive 5 in this case. Okay. All right, number 4. x minus 9 is greater than, and let me rewrite that, greater than negative 5. Again, we're trying to solve for x, so that's going to prompt us to add 9 to both sides, leaving us with x is greater than negative 5 plus 9 is 4. And again, we did addition across the inequality sign, so there's no need to change the direction of the inequality sign. And if you want to check your answers, there they are. One's x is less than or equal to 1. 2 is x is greater than or equal to 8. 3, x is less than or equal to 5. And 4, x is greater than 4. So 4 more to do. We have 1/2 x is greater than or equal to negative 3. Again, we want to get x by itself. That's our goal. So that's going to prompt us to multiply both sides by 2. And multiplying 1/2 by 2, that becomes 1. So that just leaves us with x greater than or equal to negative 3 times positive 2. That's going to be negative 6. And since we multiplied by a positive across the inequality sign, we do not have to change the direction of the inequality sign. Let's go ahead and work on this one. Negative 3 is greater than x over negative 7. Again, I don't like how this is written, so I'm going to rewrite it. Negative 3 is greater than negative 1 over 7x. That's the same thing. Again, we're trying to get x by itself, so we're going to multiply this side by negative 7 and this side by negative 7. So negative 7 times negative 3 is going to be positive 21. As you noticed, we multiplied by a negative 7 across the inequality sign. So that's going to prompt us to change the direction of the inequality sign. And negative 1 over 7 times negative 7 is just 1. 1 times x is just x. So in this case, we did have to flip the direction of the inequality sign since we multiplied across it by a negative. Number 7 is 5 plus x is greater than or equal to 7. Again, the goal is to get x by itself, so we're going to subtract 5 from both sides. That leaves us with x is greater than or equal to 7 minus 5, which is 2. Again, we subtracted across the inequality sign. Addition and subtraction does not affect the direction of the inequality sign, nor does multiplication or division by a positive. The only thing that affects the direction of the inequality sign is multiplication and division involving a negative across the inequality sign, okay? And finally, we have x over 3 is greater than 5. Again, I want to rewrite this. 1 over 3x is greater than 5. To get x by itself, we're going to multiply this side by 3 as well as this side by 3. 1/3 times 3 is just 1. 1 times x is x. That leaves us with x is greater than 5 times 3, which is 15. Okay? So if you wanted to check your work, we have 5x is greater than or equal to negative 6. X is greater than 21. X is greater than or equal to 2. And x is greater than 15. So that's all I have for you in this video. Again, in this video, just to recap, we reviewed the rules for solving and graphing inequalities, and we worked on some one-step inequalities. All these topics that we covered today are the groundwork for solving inequalities with word problems, as well as solving two-step and multiple-step inequalities. So if you felt this video was pretty easy, that was the purpose. But if you stay tuned for the other two videos, you should see that we're going to ramp up the difficulty pretty quickly. All that said, I hope you found this video helpful. If you do find my content helpful, feel free to subscribe to my channel. I'm actually in the process of uploading videos for people who need more review of in-depth topics before they start doing practice tests, including this one. So, as always, I encourage you to leave some feedback in the comments section below. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.